Over the course of the last couple of decades, we've been able to collect genomic data, so people's genome sequences or other forms of sequence variation, to be able to make some decisions on the basis of that mutational data, if you will, on health outcomes. And they're around 30% of health outcomes dictated by what it is that our genetic background looks like. And then finally, we have exogenous data, so data collected by things like Fitbits in real time, so heart rate monitoring in real time, so that you know what your daily inflection points are with regards to how your heart rate is working with regards to your intake of calories or your exercise level. And it turns out that, of course, these exogenous factors, the way in which we lead our lives, are the ones that have the most profound impact on our health outcomes, around 60%. So with that as a backdrop, what we thought is we should be collecting data that looks very similar to that within and outside of the farm gate as it relates to agri-food systems. So we have a great opportunity to collect those exogenous data on the basis of the fact that we have this fantastic partnership with OMAFRA, as I've already mentioned. We operate 15 field stations with them across the province of Ontario, covers 3 growing zones, literally from southern Ontario, which is the equivalent of Northern California, right up to, we have stations in New Liskeard and Emo, that are effectively at the same latitudes as northern Wisconsin, for example. So covering a wide variety of growth zones, a wide variety of different soil types, production types, and collecting data from across those in a digital fashion and infusing those into our decision-making systems is really what we intended to do. But of course, on the other end of the spectrum, we also have genomic data that we're collecting, whether it's someone like Bonnie Millard, who's collecting data with cattle, both beef and dairy cattle. She was recipient, I should note, of one of the very prestigious Governor General's Innovation Awards this year, one of 6 awarded in Canada for her innovation on increasing immunity within cattle and thereby decreasing antibiotic use. So we are looking at collecting genomic data, and people like Ali Navabi there on the left-hand side of the photo, they're one of our serial breeders, but he and Ishvan Raj Khan, Peter Pauls, other people working on collecting genomic data for crops and applying it in a way that we're going to hear in much more detail later on today within this particular workshop. Being at that high level on a couple of examples of how we are actually collecting data and how we see those data playing themselves out in a real world manner. So in addition to increasing livestock and crop productivity, and actually I do want to backpedal there and just say the gains that we still are able to make in terms of productivity there are immense. I talked about Bonnie's work in increasing immunity in cattle. That's now a real focal point so as to, as I said, decrease antibiotic use within the farm gate. But I should point out that here in Canada, for example, our dairy herd has decreased by half over the course of the last 30 years. So we went from about 2 million head in Canada in 1986 to around 1 million head today, and our productivity has gone up as a nation over that time period. So what that tells you is that productivity, both in terms of genetic gains and also in terms of agronomic gains, animal husbandry gains, have really been spectacular over that 30-year time period. The same is also true with crops. I don't need to be telling people from Syngenta about their business, so, and again, we'll be hearing more about that later on today. So as I said, I want to drill down on a couple of specific examples in the remaining minutes. One of them is the application of data that we collect in real time that I'd already referenced with regards to dairy. So on the left-hand side of the picture, what you can see there is a cow, and I hope you can see her, is a cow standing in a De Laval robotic milker. So we have one of those at Elora, and indeed many farmers in Canada have those. In the 11,000 farms that dairy farms we have in Canada, around 1/10 of them are employing some sort of automated milking means. So this is again done ad lib. So the cow, when she decides that she needs to be milked, walks into the milker. There's an arm that goes underneath her while she enjoys a nice meal there out of the bin that you can see. She's got her head up right there because she's obviously wanting her picture taken. But normally she'd have it in a feed bin that's sitting there, getting a nice treat, while a robotic arm goes underneath, attaches the milking apparatus to her udder, and then provides in real time a digital readout of not only the quantity factors but quality factors related to that milk. So through a tool called Herd Navigator, we're able to actually document a number of parameters in that milk, including things like ketone levels to monitor ketosis, as well as hormone levels to measure whether she is going to go into heat. On the right-hand side, you can see close up those accelerometers that I was referring to, as well as the RFID tags. Those accelerometers allow us to detect rumination, mastication, as well as movement. We use ones on the hooves to detect movement around the barn. The one that's around the neck there is really for rumination. So whenever the cow is chewing, you get a record in real time of the fact that she's done that over that time period. So we can use those correlates to we can use those real-time data, if you will, to start to make predictions around the general health and well-being of the cattle within the barn. And I'm going to provide you with two graphs in the next slide. I think I have 3 data slides, which, by the way, for a plant genome biologist and someone who does work on, we submitted a paper last week to Nature Biotech on the application of deep learning for using epigenome markers to select for poplar trees. So it really hurts me to be presenting a slide with a presentation with so little data in it. But in any case, here's one of those data slides. And really what I'm meant to be illustrating here is the application of those data as an early predictor of welfare or health of the cattle within this particular environment. And this is wonderful work that is done by Professor Trevor DeVries. And just of last week, newly minted PhD student, newly minted PhD Megan King during her PhD studies did this work. And so what Megan did was to take those data that I described to you. So in this case, we're looking at rumination time, so the rumination data. The upper line there, the blue one that you can see there, is healthy cows, so that's the extent to which they ruminate over a day. And what you can see in the red bar is the extent to which cattle that eventually had mastitis ruminate over the course of the day. And what you're looking at is times pre-diagnosis of mastitis by using a microbiological method to monitor mastitis. So here, what the star is meant to indicate is the point of divergence in terms of significance, where you are able to delineate between cattle that have mastitis and those that don't have mastitis on the basis of the rumination data. So this is an early predictor for the health of the cow without having to use an interventionist approach. All you've done is monitored her moving her jaw effectively as she masticates, as she ruminates. So really quite impressive. A way then to have what people are calling precision agriculture, to have an intervention on that cow before she actually starts to show a yield loss with regards to her productivity and correcting that particular problem within your barn. And here's a great example. Here's using the milk yield data. Again, you see a drop in yield for those cattle over time. The star indicates the inflection point at which there's a significant drop in productivity through that milking data in advance of being able to document that the cow had mastitis. So really quite impressive means here then to use data as a predictor for performance and health within herds. The thinking is now that we can be using better methods for doing our predictions, for doing our modeling. These were just simple statistical analyses, but of course we anticipate the application of, I'll call them machine learning techniques to be able to, technologies or methodologies to be able to make better predictions in the future on these and other data within the farm data. Because it's not just these sort of data that we collect. As I said, through a tool called Herd Navigator, we're able to collect other molecular data effectively in real time from those cows as they are being milked. Our idea here is that eventually what we will be creating is a suite of innovations, such as a handheld phone app, that allow us to inform farmers of when it is that their cows are suffering from a particular malady, in this case ketosis. So using a tool that we've already developed called iKetone to have early monitoring of ketosis so that you can make this simple intervention that's needed to avoid that problem. It costs around $300 a head within our herds. And therefore is relatively problematic and is fixed so easily. All that you need to do is to increase the feed rate for that particular cow to overcome that. So it's data informing practice, simple interventions, and making the whole process that much better. And we can do the same thing not only for livestock but with crops, as I've already indicated. Somewhere in the order of 100,000 different large tractors or combines of this sort here in Canada right now, collecting data in real time, literally down to the square centimeter level in terms of analysis of productivity. We can now use those data as you can see here by Virginia Kapmutras and Justin Adams have done. Here, taking those real-time data, those real-time collected data, yield data, and applying it to land use models. So what we've done here is to look at two different land use cases, one with no tillage maize, another with conventional maize. What you're looking at is fields, and each of the pixels there represents, I think my memory serves, it represents a 1/2 square meter, so it's still fairly large resolution, but it allows you to look at on those plots at where, if you were to apply those two different agricultural practices, where you would observe a loss, an economic loss versus high profit. And so that can then lead to changes in practice, applications of both seeding rates. So if you say that you're going to have for example, loss in a particular area, you might decide that you aren't going to expend seed or fertilizer or pesticide in that particular part of the field, thereby having greater savings and lower inputs into the environment. So another example there. And I've already mentioned, finally, another example of where we can apply these data analytic methods, and that is with regards to traceability and authenticity. And right now we've got a project underway working together with Bob Hanner and Rosita Dara and IBM to make use of the sort of data that we collect and using it as a means by which to have traceability at each stage of the value chain. To use blockchain as a mechanism by which to lock that in at each stage of the value chain, to have that authentication so that you don't have the problems with regards to mislabeling and misprovision of food at the far end of the value chain when it reaches the consumer. So those are the sorts of things that we're doing then within the context of food from thought. The challenges that we have going ahead our data availability, including cyber infrastructure. Here within Canada, within urban environments, all of us expect that we have Wi-Fi. The same is not true within urban communities, so being able to have the cyber infrastructure in place to be able to take the data off the farm gate and move it into the analytic platforms that we need is going to be an ongoing challenge. Data management and harmonization, also a challenge. I showed a John Deere combine a couple of minutes ago, but of course farmers choose different combines, and even within the same farm, they may have a John Deere combine and a Kubota tractor and an International Harvester feed bin. So they'll mix and match, and unfortunately those different companies make software that doesn't necessarily talk spectacularly to each other, and so having harmonization there really crucial. Having harmonization across geographical domains also important, and thinking about how we harmonize our data from one place to another really important as well. We have, for example, in Canada, farms of hundreds of acres in size. In India, it's mandated that farms must be around an acre in size. So very different land uses. How do we take data from one environment and apply it to another if we want to change global food systems? Data governance and security also going to be immensely important. It will come as no surprise to you. Those of you who wear Fitbits, you all want to know how you're doing in terms of your health. You want access to your data so that you can make decisions around changing the way in which you're living. And you want your data to be compared against other people's data so that you can say, and I love this, when I look at my heart rate data and it says 61, excellent, 44 is good for your age group. I want to know how well I'm doing against my counterparts in my own age, but I sure as hell don't want them to know my data. The same is true for farmers as well. They very much want to know how they're doing relative to other farmers, but they are small, medium enterprises. They are business people, the 200,000 farmers in this country, and they're very touchy about how their data are shared with other people. So we're going to have to be very careful around governance and security. And then finally, and this is the bit I guess that concerns most of the people at this particular conference, we need to think carefully around what our data analytics look like. What are the different approaches that we're using, and are we making sure that, again, that we've got harmonization across multiple platforms? So I'm going to finish with what I view as being the biggest challenge, actually, and it's a quote by William Gibson, and that the future is here, it's just not evenly distributed. So we do have challenges within the agri-food sector, as we do within other sectors, to make sure that that future is evenly distributed, so as to be able to have the changes in global food systems that we want to see under programs like Food from Thought. And with that, I'll finish. I see I'm exactly on 9 o'clock. We started late, and so thank you all for your time.